In this video, we are going to talk about parallel and perpendicular lines. Now, in order to do this topic, you need to know a ton about slope. Okay, and you also need to be very used to the equations y equals mx plus b. Okay, so slope-intercept form. Now, what are you going to be able to do here? Well, you have to be able to determine if two lines are parallel or perpendicular. You need to explain and determine a number's negative reciprocal. Okay, so that's kind of a new word there, negative reciprocal. But we'll talk about what that means. And then you have to describe why two lines with similar slopes are parallel or negative reciprocal slopes are perpendicular. Okay. So first off, I kind of want to mention and remind you what parallel means. Parallel means lines that will never touch, and that's because they're perfectly parallel to each other. So these two lines here are parallel. And if they continue on forever and ever, well, since they're both going in the exact same direction, so same direction, they'll never end up intersecting. Perpendicular is like a floor and a wall. That's where you have two perfectly straight lines meeting, and they create a 90-degree angle. So this thing is perpendicular. Okay. So they create a 90-degree angle. Now let's quickly talk about parallel lines. So parallel lines, these lines have the same slope. Okay. So it's two equations with the same slope. Parallel lines will never intersect if they have different y-intercepts. Okay, so if you have the same slope but different y-intercepts, you're never going to intersect. If two equations both have the same slope and y-intercept, well, that means they're just the same equation. This might seem really obvious, but remember, same slope a single slope can be represented in multiples of different ways. So if you are confused by what I just said there, you definitely want to go check out one of my other videos that has to do with slopes. So how similar fractions create some confusion. Okay, because remember, if a slope has, let's say, 6 over 1, that can also be represented as 12 over 6. Oh, not 12 over 6. 12 over 2. And that can be also represented as 18 over 3. So these are all the same slopes because they're similar fractions. So if you're a little confused on that, you definitely want to go watch that video. Anyways, slopes can be represented in infinite ways due to similar fractions. So exactly what we were just mentioning there. Okay. So this means two equations can look different, but actually be the exact same. So here, our example, negative 3x plus 5 and y equals negative 9 over 3x plus 5. Well, these are the same equations because these numbers can be both divisible by 3, and that will form y equals, well, negative 9 divided by 3 is negative 3. 3 divided by 3 is positive 1. X plus 5, so this equals negative 3x plus 5. So you can see that these are the exact same equations, okay? So let's see some examples of parallel lines here. So as you can see, these are parallel because their slopes are the exact same. So slopes of both equations, or both lines, are 2 over 3. And since they have different y-intercepts, so this one has a negative 1, this one has positive 4, they are perfectly parallel. Over here, it's the same idea. So in this case, it's a little hard to tell, but these are two parallel lines. Now, what do you notice about these? Well, they're not in slope-intercept form, but they do have the same coefficient next to next to x, and the same coefficient next to y. If we converted these both to slope-intercept form, we will be able to see that they have the exact same slope. So what I can do here is I can subtract 3x from both sides. So I will end up getting negative 2y equals negative 3x plus 2. And I can divide negative 2 by every single number. And this will end up being y equals positive 3 over 2x. 2 divided by negative 2 is negative 1. So this equation is y equals 3 over 2 x minus 1. And we could solve this equation and see it in slope-intercept form. So 3x minus 2y equals negative 2. I can subtract 3x from both sides. That gives me negative 2y equals negative 3x minus 2. And then, then I will divide by negative 2, and I'll divide every single number by negative 2. And this will give me y equals positive 3 over 2x, and this gives me plus 1. So recognize they have the exact same slopes, therefore we already know they're parallel, but they have different y-intercepts. So these are different. So since they have different y-intercepts but the same slope, they are therefore parallel. Okay, so hopefully you're seeing why the slope-intercept form is definitely the most useful. But it is important to note, if you can create similar coefficients next to the x variable and the y variable in this fashion, then you know they are parallel. Now, before we move forward about perpendicular lines, you want to know all about negative reciprocals. So the negative reciprocal of a is negative 1 over a. So a reciprocal is essentially just taking a number and flipping it, and then you apply a negative to it. So the negative reciprocal for 2 would be negative 1 over 2. The negative reciprocal of negative 2 would be positive 1 over 2. See how we just changed the signs? The negative reciprocal of 1 is negative 1 because this can be seen as 1 over 1, and flipping that isn't going to do anything, so we're just changing the sign. The negative reciprocal of negative 1 would be positive 1. The negative reciprocal of 1 over 3, that would be negative 3 over 1, which is simply negative 3. And the negative reciprocal of negative 4 over 3, well, that we're just going to flip and change the sign to positive. Negative reciprocal of negative 2 over 9, again, we're going to flip and change the sign. So hopefully you see that negative reciprocals are pretty easy to find. You're essentially just flipping the fraction that they are and then applying the opposite sign. Okay? Now, perpendicular lines, you need to know what a negative reciprocal is in order to understand perpendicular lines. Two lines that intersect at 90 right angles. So these are what perpendicular lines are. Lines that have slopes that are negative reciprocals of each other are perpendicular. So if we look here, the slope of my orange line is 3. The slope of my blue line is negative 1 over 3. Well, these are negative reciprocals, right? So if I took 3 and I flipped it and applied a negative, it looks like they are negative reciprocals. So 3 and negative 1 over 3 are negative reciprocals. So anytime you have a negative reciprocal for slopes, you know those two lines create parallel lines, perpendicular lines. So it is often easiest to tell if two lines are parallel or perpendicular by simply putting both equations in slope-intercept form. So here, identify parallel and perpendicular lines. State whether the lines in each pair are parallel, perpendicular, or neither. So this one, if we look, you want to look at their slopes first. So they have different slopes. They have different slopes. So m equals 1 over 2 on our left side. On our right side, m equals 2. They are, 1 and 2, are reciprocals, but what's the issue? They're not negative reciprocals. They're both the same sign, so they are not negative reciprocals. So since they're not negative reciprocals, that means they are not perpendicular. They're not parallel because they'd have to be the same, so they're neither. They're neither. So in order to be perpendicular, you have to be a negative reciprocal. You can't simply just be a reciprocal. Okay. Let's look at this question over here. So remember, always look at the slopes first. So my slope here, m equals 3. My slope here is 6 over 2. So at first glance, you say, hey, they're different. But they're not different. Because similar fractions, I can divide both these by 2. And what do you get? You get 6 divided by 2, which is 3. 2 divided by 2, which is 1. So 3 over 1 is simply 3. So these two have the same slope. So they are parallel. Let's move on to this last one. So y equals 2 over 5x minus 6, and then you have 5x plus 2y minus 8 equals 0. This is not your slope. Why? Because this is in general form. So if you haven't watched my previous videos about general form, you need to go watch that, because now we have to convert this into slope intercept form in order to compare it to this equation. So I'm going to convert. So what I'll do is I'll take 5x plus 2y minus 8 equals 0, and I'm going to solve for y. So what I'll end up doing here is I'm actually just going to subtract 2y from both sides. You haven't seen this method. So 5x minus 8 equals negative 2y. And now all I have to do is divide everything by negative 2. And what we'll end up getting is we'll get 5 over negative 2, which is, you can't simplify that, negative 5 over 2x. Negative 8 divided by negative 2 gives me a positive 4. And then negative 2 divided by negative 2 gives me a y. And don't forget your equal sign. Now, remember, our brains like it when our y value is on the left side. So I'm going to make this y equals negative 5 over 2x plus 4. And now here we can really see. Here's our slope. Okay. On this one, here's our slope. So we're comparing a slope of 2 over 5 to a slope of negative 5 over 2. Well, hopefully you notice here that we have a reciprocal and it's a negative reciprocal. So these are negative reciprocals. And what happens when you have negative reciprocal slopes? That means that these two equations are perpendicular. So there's your solution. Because their slopes are negative reciprocals, you know they are perpendicular. Okay, let's see 2 more examples, and then we'll be on our way to finishing chapter 6, if we're going in that order. So let's write the equation of a line that is parallel to 3x plus y plus 3 equals 0 and passes through 5 and negative 6. Express the equation in slope-intercept form and in general form. So we need a line that is parallel to this equation. So we need a line that has the slope of this equation, needs same slope. So first off, in order to start determining what type of slope we need, well, we need to figure out the slope of this equation in the first place. So what I'm going to do is I'm going to solve for y. So I'm going to subtract 3x from both sides. I'll get y plus 3 equals negative 3x. And I will subtract 3. So I get y equals negative 3x minus 3. Now, in order to be parallel, so my line needs to be parallel to this. My line must be parallel. So it needs the same slope. So in order to have the same slope, my slope has to be negative 3. So m has to be negative 3 on my new graph, or my new equation. This equation also needs to go through point 5 and negative 6. So what do we have here? We have a point and we have a slope. So this is the slope and point on my equation. Well, what can I plug in when I have a slope point? So here I'm going to use the slope point form to find the equation of my graph. And remember, the slope point form is y minus y1 equals m times x minus x1. So here I'm going to make this point x1 and y1. So now I can just simply plug these in. So 5 is going to go where x1 is. Negative 6 is going to go where y1 is. And then negative 3 will go in for my slope. So I can plug these things in here. So y minus y1, which was negative 6, equals slope, which was negative 3 times x minus 5. So my slope is negative 3, x1 is 5. And from there, now I have it in slope point form, so I'm going to clean this up, a negative and a negative, that makes it positive, so y plus 6 equals negative 3x minus 5. So there's my equation in slope point form. And from here, it's simply converting it into slope intercept form and then into general form. So let's make it into slope intercept form. And what I'll do is I will bring in my negative 3 and distribute. So that will become y plus 6 equals negative 3 times x, which is negative 3x. Negative 3 times negative 5, which is positive 15. And then I'm going to subtract 6 from both sides. And this will give me y equals negative 3x. 15 minus 6, that gives me positive 9. So there is my slope intercept form. And as we can see, we have a slope of negative 3, so that means it will be parallel to this line here. And we have a y-intercept of positive 9. Okay? And then from here, we want to put it into general form. Now remember, general form is ax plus bx plus c equaling 0. And recall that a has to be a positive integer. And then b and c simply have to be integers. And remember, an integer is negative 3, negative 2, 1, 0, 1, 2, all the way up to 1,000,000. Okay, as long as it's a whole number. So how do I make and convert y equals negative 3x plus 9 into general form, well, all I have to do is subtract y from both sides. So I'm going to subtract y from both sides, and I'm going to put my values with x first. This should say, sorry, this should be a y here. And then my y, and then my constant. So I will put 0 equals negative 3x minus y plus 9. So all my numbers are in fact integers, but remember a has to be a positive integer. So I'm going to multiply everything by negative 1 and switch the signs. So 0 equals 3x plus y minus 9. And now I have my equation in general form. So if you have any questions with that example, please come in. That pretty much reviewed everything we've learned up to this point. So this last little section definitely takes into consideration all that we've learned and apply it in multiple different ways. So let's do one more example, and this will be example 4. But in this case, we want to write the equation of a line that is perpendicular. So we're not dealing with parallel anymore, we're dealing with perpendicular to the equation 4x minus y minus 12. And this equation will pass through 8 and negative 6. So again, it wants it to be expressed in slope-intercept form and in general form. So recall, in order for two lines to be perpendicular, your slopes must be negative reciprocals. So we need to determine what the slope of this equation is so we can take the negative reciprocal of it. So I'm going to solve for y in order to express it as slope intercept form. So to be nice to myself, I'm just going to add y to both sides, and I will get 4x minus 12 equaling y. And recall that our brains usually imagine our y being on the left side of the equation symbol. So we'll write it in that form. So we get y equals 4x minus 12. So what do we notice? Well, the slope here is 4, so m equals 4. And in order for our line to be perpendicular to this thing, we have to have a negative reciprocal of this slope. So our new line will have the following characteristics, where its m value will be negative 1 over 4. So I took the reciprocal of 4 and I changed the sign. So now I have a negative reciprocal. Recall that it told us that it wants this line to go through the point 8 and negative 6. So we'll also have a point at 8 and negative 6. So when our x value is 8, our y value is negative 6. Now, from here, what characteristics do we have about this line? Well, we have its slope, and we have a point that exists on the line. So we should start off by representing this line in slope point form. So let's bring up our work and let's write it into our slope point form. So recall that slope point form is y minus y1 equals m times x minus x1. In this case, the only point that we're given will be x1 and y1. So my 8 will be x1, and my y1 will be negative 6. And here, our slope, negative 1 over 4, will be our m value. And now it's a matter of just plugging it in correctly. So y minus y1 being negative 6, so I'll use brackets, equals our m value, so our slope of negative 1 over 4, times x minus x1, and our x1 value is positive 8, so we'll simply put an 8 there. And we can clean this up a little bit by making these two negatives a positive. So y plus 6 equals negative 1 over 4, x minus 8. So there is our slope point form. And now it's a matter of converting like we did above. So in order to convert this into Y-intercept form, I'm going to have to distribute this -1/4 into the brackets and solve for y. So let's start off by distributing our -1/4 inside. So -1/4 times x, that's simply -1/4x. And then -1/4 times -8. So I'll put the subtraction symbol here, and I'll put my 8 value and -1/4 in brackets. Okay, now recall that two negatives multiplying together will make a positive, so those cancel out. And 8 times 1/4, when you multiply a whole number by a fraction, you multiply the top number by your whole number. So it's 8 times 1/4. 8 divided by 4 simply gives me 2. So we will end up getting y plus 6 equals -1/4x. Remember, our negatives cancel out, so this will be positive 2. And then we will subtract 6 from both sides. So we will get y equaling -1/4x. 2 minus 6, that gives me -4. So it looks like our equation will be, in fact, perpendicular to this line, because this line has a slope of +4. This line has a slope of -1/4, which are negative reciprocals, and we have our y-intercept at -4. So there is our slope intercept form. And finally, we simply have to convert this into general form. Now remember, general form is easiest to go from slope intercept form because all you're doing is subtracting y from both sides. So what I'm going to do is I'm going to take my slope intercept form and I'm going to subtract y. And remember, you want it to be in the form ax plus by plus c equaling 0. So I'm going to put my y value in the middle. So I'll get 0 equals -1/4x minus y minus 4. And recall that all these values have to be integers, and this has to be a positive integer. So I have to get rid of this denominator. And remember, in order to get rid of a denominator, you multiply by the lowest common denominator. So the lowest common denominator is just 4 because that's the only denominator showing up. So I'm going to multiply this by a negative to get rid of the negative in front of my coefficient of a, and multiply by 4 to get rid of my denominator of 4. So let's multiply by -4. And now we have to distribute -4 into my brackets. And this will become 0 equals -4 times -1/4. Well, that will simply become +1 because you get negative and a negative, which is a positive. 4 dividing 4 gives you 1. So you'll get +1x, -4 times -y. That gives me +4y. -4 times -4 gives me +16. And now all of our rules are met, that every coefficient is an integer and that my a value is a positive integer. And this is the equation in general form. So this last little section of this unit is definitely a little bit tough because you need to know everything prior to it. So if you're not feeling super confident in knowing how to get your slope point form, your slope intercept form, and your general form, you definitely want to go back and review before attacking this section. If you're at all confused, please come in and ask questions and complete any assignments that have been assigned. Have a good day.